Assalamualaikum and good day to Dr. Ilman. Today we're going to present our poster regarding to belting optimization study by using bed friction analysis, which is based on lab bed friction. Next, we go to objective. The aim of this study that we need to achieve from this lab is to investigate the effect of different angle of contact and material used in belting, to relate the coefficient of friction according to the changes of angle in contact and material used using capstan equation, and to recommend the most suitable angle of contact and material used in belting for optimum usage. Next, we go to introduction. In belting system, there are two important factors that need to be considered. One of the factors that need to be considered is the angle of contact in between the bed and the wheel. Different angle in contact give different coefficient of friction value as it will affect the friction force between bed and wheel. Other than that, in addition, material used in belting system plays a role of give different value of coefficient of friction. In this study, we run bed friction test method by using capstan equation or Alsterwin's formula, which used to explain the relationship between the angle of contact and the coefficient of friction. Capstan equation is F load over F whole equal to exponent to the power of mu alpha. F load is greater force on the tension side, while F load is smaller force on the pulley side. E equal to exponent, mu equal to coefficient of friction, while alpha equal to angle of contact measured in radians. Next, I will pass to Hakim Basir.
To get the optimum result for a belting system, belt friction test is used to get the best combination of belting system in terms of angle of contact and material used for the belt. This friction test will study the angle of contact and material used for the belt. What is the best angle of contact for belting system and which type of belt will give the optimum result for the belting system. For the first experiment, different angle of contact between belt and pulley by using hem rope as the belt. The angle are 30 degree, 60 degree, 90 degree, 120 degree, 150 degree, and 180 degree. In second experiment, different belt will be used on gray cast iron pulley on a 180 degree angle of contact. The belt used for this experiment are hem rope, flat leather belt, and rubber belt. The setup for this experiment is shown as the figure. Both number 7 and 8 are the springs balance for F load and F hold. Next, Jaafar will explain about result.
Next is the result and discussion. Based on the result run by the lab, we can get two graphs. The first graph is the coefficient of friction versus angle of contact. Based on the graph 1, as the angle of contact increase, the coefficient of friction also decrease. The second graph is the graph of ratio versus angle of contact. The graph ratio is the caption equation. F1 equal to F load, which is force of the tension side. F2 is the F all, is force of the pulley side. The graph show that as the angle increase, the ratio also increase. Next, I will pass to Haikal to explain the conclusion.
For the conclusion of this study, we have come up with three category of conclusion. The first one is the optimum parameter. Second, good material, and the last one is force required. For optimum parameter, we can say that the bigger the angle in contact, the lower the coefficient of friction. For good material, as by the result of this lab, we have found that ham with gray cast iron produce low coefficient of friction, but need high force to move the belting system. For leather and gray cast iron, it only requires low force to move the belting system because the coefficient of friction is high. Then for the force required, as the coefficient of friction is become higher, the force needed to move the belt and wheel is low. Uh, However, if we want to determine the parameter of the belting system, we need to know that the aim of the belting system. For example, belting system A need high force to operate the belting, but belting system B only need low force to operate the belting system. So now we know how to manipulate the angle of contact between the belt and the wheel, and what is the best material to be used to run the belting system at optimum performance. That's all from us. Thank you for your time and good day.